This video describes how to configure the surface and downhole parameters of the rear lift RPC and assumes that the load cell and position sensor have already been installed on the pump jack by a qualified set of operators. Please review all safety messages in the rear lift rod pump manual before following the steps contained in this video. To learn more about the rear lift RPC and SCADAPack 474 Smart RTU, see the other videos in our series. First, we'll log in as an admin or expert user. Let's begin by configuring the surface parameters of the rear lift RPC. For this example, we'll configure Pump 1's parameters. Before beginning, information on the pump jack's design, including its API designation, gearbox size, current stroke length, and direction, should be handy. From the home screen on the rear lift RPC's HMI, press Config menu. From the Configuration menu, press Well Configuration. From the Well Configuration menu, press Pumping Unit, and the Pumping Unit screen will now appear. Let's set the pump jack type. The rear lift RPC supports conventional, Mark II, and air-balanced pump jacks. If you know the API designation, an API designation starting with C, B, or RM corresponds to a conventional pump jack. An M corresponds to a Mark II pump jack, and an A to an air-balanced pump jack. If it's a conventional pump jack, you will need to set the direction of the pump. Select clockwise or counterclockwise. Depending on the direction of travel, this can be viewed by looking at the pump jack with the horse head on your right and watching the motion of the crank. The last term of the API unit designation will correspond to the maximum stroke length of the pump jack. The stroke length can be modified by adapting the position of the pitman arm on the crank. The stroke length can also be measured. Enter the current stroke length. The gearbox ratio is used by the rear lift RPC to derive the speed of the motor. This is not required to run the pump, however. The ratio may be on the nameplate and can also be derived from the gear reducer code. The name parameter is used as a convenient way to identify an individual pump in the HMI, but is not required to run the pump. If you want, enter an alphanumeric name for the pump of no more than 20 characters. The API dimensions are used as a part of the optional gearbox torque protection calculation. If you intend to use the gearbox torque protection, enter the API dimensions from the pump's nameplate. As with the stroke length, the R dimension will vary with the position of the pitman arm on the crank. Now press the double arrow right button to see the Pumping Unit 2 screen. Here you can enter the rear lift RPC's load cell size. It's the maximum weight the load cell can measure. Typical rod pump load cells can measure a maximum of 30,000 or 50,000 pounds. The status parameter for load displays the current load measurement and can be used to verify the connection of the load cell when commissioning, as the load cell will update through the stroke. We can now configure the rear lift RPC's position sensor. The rear lift RPC can use an inclinometer or proximity sensor to provide position measurements. Starting with an inclinometer, let's set the type to inclinometer. Depending on the orientation of the inclinometer direction can be set to normal or inverted. The status will then display the current angle of the walking beam in degrees. This can be used to verify the connection of the inclinometer when commissioning, as the angle will update through the stroke. Monitoring the reported angle through a stroke can be done to verify if the inclinometer direction should be set to normal or inverted. If you are using a proximity sensor, set the type to proximity. If you measured the proximity angle during installation, enter the proximity angle. Next, we enter the Hertz to SPM ratio. This parameter is the ratio of prime mover speed to the speed of the pump. This is needed with a VFD to ensure that the rear lift RPC can accurately convert the prime mover or motor speed to strokes per minute. If you know this speed, enter it. If you do not, you can use the calibrate function and the rear lift RPC will run at a fixed speed for 2 complete strokes and automatically determine the ratio. If the ratio is set to 0, the rear lift RPC will automatically perform a calibration when the pump is started. You may wish to recalibrate the ratio after maintaining the gearbox to ensure you have an accurate measurement of belt slippage. Now we've finished configuring the surface parameters. Let's now configure the downhole parameters for pump 1. Before you begin, you should have information on your pump's tapers and stuffing box. We'll start from the pump overview screen. From the configuration menu, press Well Configuration. From the Well Configuration menu, press Downhole. The downhole screen will now appear. If you know the stuffing box friction, enter it here. The stuffing box friction can be measured by adjusting the tightness of the packing while monitoring the load cell measurement with the pump stopped and braked in place. The damping factor accounts for the fluid friction within the pump. The default values for stuffing box friction and damping factor should work for most pumps. Next, enter the depth of the anchor if the tubing is anchored, and enter the tubing size. Then enter the number of rod tapers. For this example, we'll select 2. The first set of downhole parameters is now set. Press the double arrow right button to set the rod taper parameters. This screen shows the taper parameters. Taper 1 is the closest taper to the surface, and each subsequent taper is deeper. Let's configure taper 1 by pressing Config. Enter the length of the taper in feet. Select the diameter of the taper. Select the material of the taper, steel, fiberglass, or custom. If you select steel or fiberglass, the ReLift RPC will automatically set the speed of sound in the material, the weight, and modulus. These default values should work on your pump. If you know the detailed parameters, select the custom material and manually enter the speed of sound in the material, the weight, and modulus. Now press Close and repeat the configuration for taper 2. To learn more about the ReLift RPC and SCADAPack 474 Smart RTU, access the user documentation on Exchange Shop at Schneider Electric's website.